Hey there, awesome physics students. Let's talk about parallel circuits and electricity. Before we get into the actual circuit, I want to explore a building with a physical situation that you can actually do. So you're in a building and there's an elevator on the 0th floor, and the 0th floor is like the basement. So you're below the first floor. Then you take, from the 0th floor, you go up a couple of floors and then you get out on the 2nd floor. When you get out on the 2nd floor, while you're going up, your gravitational potential energy is increasing inside the elevator. Then you get out on the 2nd floor and you walk on the floor, and the floor is level, and so your elevation doesn't increase or decrease. So your gravitational potential energy doesn't increase or decrease. So you walk along that floor for a while, and then you decide you want to go back down to the 0th floor. So you can take, there's one set of stairs that you can take straight away, and that will take you straight down to the 0th floor. Or you can walk on that floor a little longer, and if you walk down to the end of the hallway, there's another staircase that takes you all the way down to the 0th floor. Okay, so you can choose either you take the first staircase or you take the second staircase, but they both begin and end at the same place. While you're going down the stairs, your potential energy, of course, gravitational potential energy is decreasing. And again, you walk on this level floor and your gravitational potential energy does not decrease or increase, but you're free to get on the elevator and go back up again if you want. Let's draw this scenario as a circuit. So what is the device that increases your potential energy, electric potential energy in this case? Well, that's going to be a battery. So you're going to come in at 0 volts and then come out at 2 volts. And so this is a 2-volt battery. It's going to boost the charges, which are you, the people inside the elevator. Those charges are going to increase their potential energy inside that device. Then they can get out of the elevator and walk across the wire, and the wire does not increase or decrease their electric potential energy. Then they have a choice. They can go down first set of staircases, or they can travel a little farther along the wire, along the floor, without changing their potential energy, and they can go down a second set of staircases that's slightly farther away. So when they do that, they decrease their potential energy, and that's in a resistor. And if they go down this first staircase, they can go back into the battery then by walking along the wire, or they can go down the second staircase and go back into the battery at the bottom of the wire. Okay. In both cases, though, if you're in the elevator, you're one person, you're one charge, you have to choose. Either you go down this path or you go down this path, but you can't go down both. If there's 4 of your friends that come in the elevator and 4 of them get out of the elevator and then they reach this staircase situation, let's say 3 of them go down the first staircase. So that's 3 amps of current that's going down this first resistor. How many, if 4 amps came out of the elevator, 4 people came out of the elevator, then how many must go down this second staircase, this farther staircase? Well, it's got to be 1 amp, right? So in other words, whenever it branches, the number of people coming into a junction have to equal the number of people going out. Okay, you can't lose people. They don't just vaporize. They have to go somewhere. So if you have 3 going down this one, you have to have the last person go down this staircase by themselves. And then at this point, they join up again, right? This 1 amp person, this one person comes through and joins the 3 amps, the 3 people that went down the first staircase. And then when you come back here, you have 4 amps going back into the battery. Another important point is that these 3 people decrease their potential energy or their voltage. How did that voltage difference or that voltage decrease or drop compare to for the 3 people compared to the 1 person? Well, for these people, they started at the same height and ended at the same height. These charges started at the same electric potential, 2 volts, and ended the same electric potential, 0 volts. So the potential difference of these 2 things in parallel will be the same, no matter what. If it's 2 volts in this case, but if the battery was different, then if this was a 12-volt battery, it would be 12 volts to 0 volts for both of them, so that potential difference would still be the same. Okay. hopefully this gives you some analogy to lean on when you're thinking about these abstract things like current and voltage. Okay, the people are going to be acting like the current, those are the charges, and the changes in potential energy, remember potential energy is best friends with the voltage difference or the potential difference. Okay, see you later.